So question 5, we're asked to integrate a cubic over a quadratic, effectively. So we are going to express this in partial fractions, but we're very conscious of the fact that it's very much an improper fraction. We've got x cubed on the top and x squared on the bottom. And if I divide x cubed by x squared, I'm going to get some x's, then a constant, and then I'll have something over x plus 1 plus something over x plus 3. So I'm very conscious this is a cubic over a quadratic. So I'm going to have ax plus b plus c over x plus 1 plus d over x plus 3, since it's not been given to me in the question. There are other ways that you could do this. You could divide this by, you could do the long division first off. However you like to do long division, that will find your coefficients of a and b, the ax plus b, and give you some a remainder that will be over x plus 1, x plus 3, which will be a constant, and then I could do partial fractions just for that constant. But I'm going to do it with an expression that is equivalent to that in one go. So I'm going to say this is equivalent to, as we said, ax plus b plus c over x plus 1 plus d over x plus 3. So we arrive at x cubed plus 5x squared plus 1 equals ax times by x plus 1, x plus 3, plus b times x plus 1, x plus 3, plus c times x plus 3, plus d times x plus 1. Okay, let's go for the easy one first. So let's say that x equals minus 1. So x equals minus 1. So we're going to have minus 1 plus 5 plus 1, so that's 5, equals, goes, equals 2c. So in other words, 5 equals 2c, c equals 5 over 2. Not that nice a number, but hey ho, we'll go with that. So the next one we're going to choose x equals minus 3. So minus 3 cubed will give me minus 27, 4 nines are 45, so plus 45 plus 1 equals, this disappears, and this disappears, so I'm going to have minus 3 there, so minus 2d, minus 2d. So I need to tie this up. This is 46, take away 27, so 46, 36, 26, 19, so 19 equals minus 2d, implies d equals minus 19 over 2. Again, not a very nice number, but we'll check when we get to the end that we've got this right. Now, there's no other easy way to solve for these, so I'm going to go using values of x. I could create equations by putting x into any value I like, x equals 0, but much easier, just go for coefficients. So I'm going to go for coefficients of x cubed to start with. Well, on the left hand side I've got 1, and on the right hand side nothing. It's just here I've got a, so that gives me a equals 1. I might go for coefficients of x squared now. A little bit harder because I've got to have to look closely. So on the left hand side I've got 5, just a 5, and on the right hand side, oh gosh, this is a bit tricky, isn't it? So it's going to be the constant term of x times that x. In other words, it's not the number of x. I've got 1x, I've got 3x, I've got 4x times the x will give me 4x squared, so 4a, that's a little bit confusing, plus b, no c's, no d's. So we know a is 1, so this leads me to b equals 1. So let's write out our expression. We're going to have x plus 1, not c, oh 5 over 2, plus 5 over 2 x plus 1. And d is that horrendous thing, minus 19 over 2 x plus 3. Now, I don't know if this is right or not, but I'm just going to do a quick check. I'm going to put an x equals 0 and see what I get. So this is my check. So I just want to make sure before I go and do more stuff that this is correct. So I'll say x equals 0. So I'm going to get, this is 0, so that'll be 1. So that'll be 1, and that will be 1 times 2, which is 2 over 5, so plus 5 over 2. And this will be 3 times 2 is 6, so minus 19 over 6. Okay, so let's put it all over 6, so it equals 6 plus 15 minus 19 over 6 equals 21 21 minus 19, 2 over 6 equals 1/3. Okay, if I go back to my original expression here, and put in x equals 0, I get 1 on top and I get 3 on the bottom, 1/3. Check, orig equals 1/3, tick. So I know that the original expression gives me 1/3 as well if I put in x equals 0. So I'm happy. I'm going to move on. That's just my check.